Hi everyone. Okay, so let's keep going with chapter 9 and we're going to move on to section 9.2, which is future value. So future value of any money is a combination of the principal, which would be the present value, the money you start with, and the interest that is earned on that money over the life of the investment. And the formula is that your future value equals your present value. That gets multiplied by 1 plus I. And if you remember, I is the interest for the compounding period. Then that is to the power of n. And n is your number of periods over the life of the loan, so the number of compounding periods. And if you remember, going back to BEDMAS, we must do this calculation first. We need to do the bracket to the 1 plus I, and then we need to do the exponent before we multiply it by the present value. Okay, so here's an example. Okay, so what will be the maturity value of $5,000 invested for 4 years at 6% compounded monthly? So we know our present value is 5,000. Our N is the 4 years multiplied by the 12 compounding periods in a year. So in total, over the life of the investment, the number of compounding periods is going to be 48. I is the interest rate per period, per compounding period. So it's your annual interest rate, which is your 6%, divided by 12, which is your number of compounding periods in a year. That gives you 0.5%. So to put it in our formula, it would be 5,000, which is your present value, the 1.005, right? Because we had to take the 0.5 percentage and turn it into a decimal. And then the 1.005 exponent 48. Okay, so let's walk through how we did that. Okay. So you want to put 5,000 into your calculator. So 5, 1, 2, 3 for your zeros. We want to multiply that. Okay, so you hit your multiplication. And then we want to put our bracket, or you know what it is, right? So you can either put your bracket and put 1 plus 0.005, or just put 1 plus 1.005 in your brackets. And then that will save you a step. Okay. And then what we need to do is we need to hit the y to the power of x. So for what's in your bracket, you've got 1.005 y to the power of x. And then we're going to hit 48, and then we're going to hit equals. And it's going to work out to 6,352.4458. Okay. All right. So give these ones a try. What will the maturity value be of 3,000 invested for 5 years at 12% compounded monthly? Calculate the future value of 7,000 invested for 20 months. At 5% compounded quarterly. What will be the maturity value of 4,500 invested for 380 days at 3% compounded semi-annually? Okay. So let's try this one, actually. And this one, many of you will be faced with in the future, maybe when you're looking at a mortgage or even a car loan from different lenders. And by being able to figure it out, it will allow you to personally make sure that you always pick the right option for yourself. So other things being equal, would an investor prefer an interest rate of 4.8% compounded monthly or 4.9% compounded annually for a 2-year period? So at first glimpse, you'd say 4.9 would be better. However, where the 4.8 is compounded monthly, and so therefore you're earning interest upon your interest upon your interest 12 times per year for 2 years, or you're getting 4.9% and it's only being compounded twice because it's only being compounded annually. So let's give it a try and see which one is actually the better option, and maybe pick in your own mind what you think before we do the calculations, just to see how it compares. Okay, so because they're not giving us a value, we can pick anything. So let's say it's $1,000. It could be 10,000. It could be 100,000. It'll both work out the same. Which one is going to give you the best option, no matter what the amount is. Okay, so if you draw a timeline, okay, I find especially for investment options and time value of money, literally drawing a timeline often helps. So we're looking at our first option, 4.8% compounded monthly. So we want the present value is at time 0, $1,000. And we have year 1 and we have year 2, and we want to know at year 2 what the future value is going to be. So we've got our present value of 1,000. We have our interest rate, our periodic interest rate at 4.8% divided by 12. So therefore it's 0.4%, or in decimal form it's 0.004. And then the number of compounding periods over the life is 2. That's the number of years multiplied by 12 per year gives you 24. Okay, so we do the calculation there and it works out to $1,100.55 if it's compounded monthly for 4.8%. Okay, so let's move on and try the 4.9. Same process, except number of compounding periods over the life of the investment is only going to be 2 because it's only being compounded once per year and then for 2 years. We've got our timeline, and this one works out to 1,100 period and 40 cents. So the 4.8% is better. It's slightly more. It's like 15 cents more over a 2-year period. But just think if we were talking about $100,000 or $200,000, so $300,000 if we're talking about a mortgage or your investments for your future retirement. So you should always go with the higher amount. Okay. So this one here is a rate change. So part way through, the rate has changed. And that can happen if you remember where we were talking about fixed interest rates versus variable interest rates. So if you have a variable interest rate, so say for a mortgage, okay, you decide to have a variable interest rate, then partway through your locked-in period, the rates are going to change depending on what the prime rate with the banks are doing. So this is something that's really good for you to be able to calculate as well. So George invested $5,000 at a rate of 4.25% compounded quarterly. So that's 4 times a year. After 18 months, the rate changed to 4.75% compounded semi-annually. Okay. What amount will George have 3 years after the initial investment? So if you look here at the timeline, being able to draw it out and put in the relevant numbers in the relevant spot, that's very important, okay? You know what they say, a picture's worth 1,000 words. So for the first 18 months, we have the periodic interest rate of 4.25% divided by 4 gives you 1.0625%, and N over the life is your 4 times 1.5, right? 4 is your compounding quarterly, so 4 times a year times 1.5 years, so your N is 6. So the future value after the first 18 months is going to be 1.010625, and put that in as your Y, and then your 6 enter when you're using the IY button. Then we're going to multiply that by our 5,000 to give us the future value after 18 months of $5,327.34. Okay, so after the first 18 months, we've gone from 5,000 to the future value of the 5,327.34. So now for the next part, to figure it out when it goes to 4.75% compounded semi-annually, we're going to use this 5,327.34 right here under your future value 1, but for the next calculation, that's going to turn into your present value. Okay, so present value of 5,000 becomes your future value. Then for the next calculation, that future value becomes that equation's present value to be able to figure out the future value. Okay, so now for the second 18 months, we have 4.75% divided by 2 gives you your periodic interest rate of 2.375%. Your N is 2 compounding periods in a year times 1.5 years, so your N equals 3, and your present value, as I mentioned, is your 5327.34. So the final maturity at the end of the 3 years will be $5,716. Okay, because once we multiply this out, you're 1.02375. Then remember to use the YX button, and then put 3 as your exponent, enter, multiply that by your 5,327.34, and that gives you the future value of 5716. And you can see here that the final value is your 5716. Okay. Wonderful. Okay, I'm going to stop the video here, and then we're going to move on to the second part of this. So we've figured out if we have the present value, how do we get the future value? Now what happens if we have the future value, or we know what the future value, what we want it to be, what does the present value have to be under that circumstance? Thanks, everyone. Let me know if you have any questions, please.